Hi guys, and welcome back to the ACE Academy. In this video, we will be looking at the proof for the sine rule. Now, just like in the proof for the cosine rule, we had a non-right angle triangle and we had to find some way to prove this rule so that we can use it when working with non-right angle triangles. Now, when it comes to our basic understanding of mathematics and geometry, we know that we are only able to work with right angle triangles and our basic trig rules. Meaning our basic trig rules and our basic trig ratios are only applicable to right angle triangles. And the same goes for the theorem of Pythagoras. So now when it comes to the toolkit that we have in order to work with these triangles, we basically don't have anything when it comes to these non-right angle triangles. So in order to prove this triangle, just like in our cosine rule proof, we are going to split this non-right angle triangle into two right angle triangles by drawing a line from one corner of this triangle perpendicular to one side of the triangle. What I mean by that is, if you look at this corner B, I drew a nice line that is perpendicular to line AC, which is a side on this triangle. And what I'm going to do over here is I'm just going to label this something. So let's say D, because I already have ABC, I'm going to label this D. Now, if I remember how to assign the sides of this triangle correctly, the side opposite a corresponding corner will have the small letter of that corner. So if I'm looking at line BC, this side will be labeled as small a. If I'm looking at corner C, I will look at line AB and that will be labeled small c. Right, and just like that, similarly, the line AC is opposite the corner of B, and hence this line over here will be labeled side B, small b, right? Now, in order for me to work with this triangle a bit better, I need to assign some sort of value or variable to the line that I have created, because that's a new value. I need some sort of length measurement to assign to it. So I'm going to just simply assign this one as h, just to make it a bit better, or I can in fact even assign it as x. Okay, and now I'm going to assign this portion of line AC from D to C. I'm going to assign that as y. So I know that from point D to point C, that is the distance y. Now, using my basic mathematics and my logic, I can see simply that AD will be the entire line AC minus this portion DC, which would be B minus y. And I have completely labeled this triangle. Simply put, the sine rule can be written in one of two ways. So the first form that the sine rule can be written in is the angle form. So we will have sine A over A is equal to sine B over B is equal to sine C over C. Now, an important thing to take note of when we're looking at the sine rule is the fact that it is a ratio, right? It is a ratio. And if I'm looking at analyzing this ratio, I could also invert this formula to make the sides the subject of the formula, and that just makes it that much easier for us to work with. So that would now become A over sine A is equal to B over sine B, which is equal to C over sine C. And that is our sine rule right there. Now, in order to prove either one of these rules, it's quite simple. Like I said, we divide our large non-right angle triangle into two smaller right angle triangles, and we are going to work with each right angle triangle separately. Okay, so on your screen right now, you guys can see that I have separated this one large non-right angle triangle into two smaller right angle triangles for us to work with, and this just makes it a bit easier for us to see, right? Now, this is the sine rule, so I am going to predominantly be working with the trig ratio sine. Now let's look at this triangle. If I am looking at the angle or the corner A, if that is my reference angle, and if I'm using sine, so let's just do that, right? Sine A. Okay, I'm going to solve for sine A, and sine A would be opposite over the hypotenuse. So opposite hypotenuse, right? And if I put that in a fraction, I would get sine A is equal to x over c. Let's look at the right hand side triangle. If I'm going to do the exact same procedure, but now I'm looking at corner C, I'm going to apply sine to this corner, so that'll become sine C, and sine C is equal to opposite over hypotenuse, and that would be x over A. Okay? Now, there is something common between these two triangles, and that is this x over here. It is common to both triangles. So if I make that the subject of the formula for both of my trig ratios that I have over here, I can equate both trig ratios. So let's go ahead and do that quickly. Making x the subject of the formula, I would get c sine A is equal to x. And making x the subject of the formula for sine C, I would get A sine C is equal to x. Now, as you can see, both of these trig ratios over here are equal to x. So if both of them are equal to x, that means that c sine A would be equal to A sine C, because both are equal to x. Let me go ahead and write that down for you guys. C sine A is equal to A sine C. Now, in order for me to get this equation over here to look something like this, I'm just going to use some basic mathematical transposition. If I divide this entire equation by C, I would obtain sine A is equal to A sine C over C. Now, dividing this entire equation by A, I would now obtain sine A over A is equal to sine C over C. Now, the way in which I did this can be further explained by what I'm about to do here. Let's look at this part of this equation a bit more, right? So A sine C all over C is actually equal to A over 1 times sine C all over C, right? Now, if I expand this out, you can see quite easily how I obtain sine A over A by dividing both sides by A. Because if I divide A times sine C over C by A, the A would cancel. That will leave me with this formula right here. Now, if I wanted to obtain the formula for sides using the sine rule and using the same method that I've just done, in this step right here where I divided by my sides, the only thing that I would do differently would be I would now divide by the angle. So instead of saying this entire equation divided by C first, I would say the entire equation should be divided by sine A first. And I promise you, you would get the exact same thing. So I want you guys to attempt that for me. And I'm sure that you would understand this a bit better. That's it for me, guys. All the best, and I will see you in the next one.